Hello everyone, this is Dr. Zach. We're going to spend some more time working with our differential equations, specifically related to growth and decay problems. Let's get started. Your lesson preview was a reminder of how to find a general solution for your differential equation dy dt equals ky. And given 2 points, you should be able to solve for the particular solution. All right, so these are especially important because we use our growth and decay models in biology, chemistry, economics, earth science, medication in the bloodstream, many different ways. There's a typical problem. If we have the half-life of carbon-14 given to us as 5,730 years, that can be used in order to write a point. If we have 100 grams of this radioactive carbon stored in a cave for 1,000 years, that's another point. We've got 0 with 100, and we're trying to write our equation. Now, since we know that this is a growth or decay problem, then dy dt is equal to ky. We've integrated this often enough that we know that y equals c e to the kt. And that if we're given t is 0, that c value is your initial value. Next, we can use the idea that the point 5,730 years goes with 50 in order to find our k value. Now, just as a reminder, when you see the log of 1/2, that can be rewritten as the natural log of 1 minus the natural log of 2, which is negative natural log of 2. So the k value can then help us figure out the question at hand, which is what is the population after 1,000 years? Now, the next question, what is the average amount of radioactivity? So I want to recall that the average value of a function can be found by taking 1 over your b minus a, and you're going to integrate from 0 to 1,000 of the function that you have written, which was 100 e to the negative k, but we know what k represents here, and t, dt. So once you figure out that average value, you can use it. Now, this next question, what is the average rate of change? I wanted to show you the difference between these two questions. The average rate of change is asking for y at 1,000 minus y at 0 divided by 1,000 minus 0. It feels like a very long time since we've done an average rate of change, but please take a look at the difference between those two questions. All right, now I want you to give question number 1 a try. Turn off the video right now and see what you can do. All right, so I really hope that you stop the video in order to try the problem yourself. First, you should find your 2 points. Understand the words proportional to the population are telling you that you have dy over dt is equal to ky, in which case once you integrate using separation of variables and substitute your 2 values in, you can come up with your equation and answer the question about the number of bacteria. All right, number 2, slightly different problem, but it's very typical of AP to put a problem like this on your exam. So Newton's law of cooling states that the rate of change in temperature is proportional to the difference between the object's temperature and the temperature of your surrounding medium. All right, we're going to let y represent the temperature of an object in a room, and the temperature in the room is 60 degrees. We're also told the cooling rate in 10 minutes. And how much longer will it take for the temperature to decrease to 80 degrees is our question. So start by writing the 2 points that were given to you. And those 2 points, of course, are going to be 0 with 100, and 10 minutes later, it's 10 and 90 degrees. So the equation, dy dt is proportional, so here's your k value, to the what's it proportional to? The object's temperature, which is Y, and the temperature in the surrounding medium. And we want the difference between those. And in our room, it is currently 60 degrees. So we have our equation written. Now we're ready to do separation of variables. dy over y minus 60 is going to be equal to k dt. Integrate. We have our natural log absolute value of y minus 60 is equal to kt plus c. All right, and now if we e both sides, we end up with y minus 60 is equal to c e to the kt. All right, now that we have our equation, it's time to substitute. We know that 100 must be minus 60 must be equal to c e to the 0. And so c is 40. Rewrite our problem. We have y minus 60 equals 40 e to the kt. All right, so now we need to figure out what is that k value. Substitute your 90 in. We get 90 minus 60 is equal to your 40 e to the 10 times k. So 3/4 is e to the 10k. Find the natural log of that. And we get the natural log of 3/4 divided by our 10 is going to be equal to k. All right, so now that we have our function, it's time to write the equation. Always write that equation. Finish it up. Y equals your 40 e to the k, which is natural log 3/4 divided by 10 multiplied by t. And don't forget that 60, so we're going to put a plus 60 in the problem. Afterwards, it's time to figure out what happens when we let 80 equal our problem. So 80 equals, set it equal to your problem, and solve this for t. And what you come up with is t equals 24.094 minutes. And it's going to take 14.094 minutes longer for our tea to cool. You have 3 more questions that I want you to work on, so stop the video and then check your answers once you're finished. All right, let's check your answer for question 2. Fairly straightforward problem. Probably be better if I'd written this as Q of T as the final solution. For number 3, you have that you have a continuous decrease, and then you're going to integrate and you come up with y equals c e to the negative 0.1 t. Now you're looking for when you have 1/5 the original amount, but you weren't told the amount that you had. You can still solve it though, because your c values will cancel. All right, so for our last problem, you need to solve your exponential problem as we've been practicing, then determine y at 100, as well as what time will it be when milligrams of as our mass. For today's lesson follow-up, page 412, you're going to find some excellent problems to practice. And then I've got 2 additional problems for you to think about. All right, that's it for today. You have a fabulous day.